All right, guys. Here's some information about the Trig Usubs. So let me I wrote some stuff up. I just got done with practice. So this stuff right here. So if you see an a squared plus a quantity squared in a problem like this for integrals, you're gonna set whatever's inside here equal to a tangent of theta. If you see a squared minus like x squared, you're going to do x is equal to a sine of theta. So the idea is when you see one of these, you're going to plug in one of those. Okay, so the problem it starts with right here is this piece right here like this. Okay, got a little color coded here. So I got 9 minus x squared. So I'm looking at this piece here. I got a number a, 9 minus x squared. So I'm going to use this one right here. Okay. Now this top problem, that should be a squared right there, guys. This top problem, you got to kind of manipulate it a little bit. So, and I don't know if you can see it. Let's see can you guys see it? Okay, good, you can. 9 becomes 3 squared. So now I've got my a squared, and then I've got my x squared. And so I'm going to let x equal 3 times the sine of theta. So x equals 3 times the sine of theta. So a couple of things we can do with this part right here. Don't worry about this just yet. X equals 3 sine of theta. I can take the derivative of x. So dx is equal to 3 cosine of theta. That's taking the derivative of this one. And then from there, I can solve for theta because I can divide both sides by 3 and I get x over 3. And then I do the inverse sine. So theta is equal to the inverse sine of x over 3. We know that this is opposite over hypotenuse. So that means this is my opposite side. This is my hypotenuse side. And then now I can actually calculate the third side, which is going to be 9 minus x squared and the square root of that side. Okay? Which, look at there. There it is right there. Okay? So this will come in handy as we tackle our answer. This comes in handy for us to get rid of some things. So let's just kind of walk through how we're going to use this stuff. I'm missing my blue pen, but that's okay. We'll just make it work, guys. So I have now made x equal to 3 sine theta. So I get 3 sine theta squared, okay? And then dx now is 3 cosine of theta. So it kind of looks a little ugly as we go, but the whole goal is that it's going to kind of clean up and we'll be able to deal with stuff real quick. Okay? So if we are going to tackle this, let's clean all this up. I can factor a 9 out of this because 3 squared is 9. So when I take a 9 out, I get 1 minus sine squared. 1 minus sine squared is also the same as cosine squared. So this is really cosine squared theta. So if I get cosine squared theta times 9, the square root of 9 is 3, and the square root of cosine squared theta is cosine theta. All over 3 sine squared theta. So then from there, I'm going to kind of keep cleaning this up. So I'm going to go up here like this. All right. So then I get what am I losing here? Something. I messed up on something. Oh, I forgot. This should be 9 right here. That should be 9 because it's x squared. I forgot to square the 9. So 3 times 3 is 9. Those are going to cancel. So I get the integral of cosine squared theta over sine squared theta, which is equal to the integral of cotangent squared theta, which is equal to the integral of cosecant squared theta minus 1. That's where I can start working with this piece here. Okay? So I can start working with that piece there. And then, what do we end up working with here? So we're gonna take the integral of this, which is gonna be theta. And so the question is what is the cosine, or, sorry, what is the integral of cosine? Sorry, not cosine, cosecant squared. So what's the integral of cosecant squared? It is going to be negative cotangent of theta. Okay? So that's going to become the negative cotangent of theta. And then this, now I can do some work with what I've got. This should be d theta, sorry. This should be d of theta. This should be d of theta. And then now I've got a plus c, because I may be off the side. Let me double check, guys. Let me double check and make sure camera's on point here. Okay, so yeah, that's a little too far over. Let me rewrite that. Minus theta plus c. So now I need to find out what cotangent is here. Cotangent is adjacent over opposite. So that's going to be the square root of 9 minus x squared over x, adjacent over opposite. And then what is theta? Theta is the inverse sine of x over 3 plus c. It got a little ugly there towards the end. So the whole goal of this stuff, guys, is to use trig identities to let them kind of cancel themselves out to where we can get to a point where we can actually work with them. So my answer is this, and remember, I have to get part of this from a triangle using what I said equal to theta. We'll talk about more tomorrow. So we'll talk to you guys soon. We'll see you later.